Hello. Oh no. Come on, it's good. Okay, I'm back for another evening, at least for me, I'm in Canada. Another evening of working on a circuit board design. So I'm picking up where I left off last time for my trike project. I have a current trike, electric trike, that I use. Put a photo on the screen. So this is the current bike, and I'm now working on the design for the next one that I hope to build, and starting with some of the electronics that will be on it. And one of those main electronic components that I wanted to integrate is this board here. This board is linked to an automotive PKE key, so it can detect when I am close to the vehicle and automatically unlock. Now the module is typically designed for a car where it's just clicking some relays, unlocking and locking, that kind of stuff. So for my application, I've actually removed some of the driver chips that were connected to the relays, and I'm able to read them as inputs on an Arduino. And through that, I gain the necessary data that I need to interface with it and authenticate this key. Because the key does have some sort of encryption, and I don't have an oscilloscope or any other way of deciphering the data being sent to the chip. So last time, what I had gotten into was a circuit design, and I left some notes for myself of what I still had to work on, and I've actually duplicated the file here, and the reason being is so that this one I could modify, because from my testing I've learned a few things that I can change. So I've duplicated the file so that I still have an original with most of the original schematic. There were a few components that I left out, a few circuits that I left out, because I do not necessarily need the data from them, such as the circuit that's driving the relays and a few other spots. Um, the other thing that I will end up doing is, so I've already confirmed the blank pits are not required by application. The other thing I have to confirm is if there's any pull-up or pull-down resistors on any of the pins. As far as I know, I've accounted for everything that needs to be accounted for. This particular resistor I will not be needing, so that can be removed. Everything else can pretty much stay the same. Now, these circuits here are inputs for the chip, and they are necessary for the chip to run correctly. What I've found out is that this regulator is, I'm going to change the value. I'm not using, yes, I'm not using that particular IC, but I wanted something in place while I was designing. But it is going to be a 3.3 volt regulator. So make note of that. The other thing I found out is on the circuit, I have added this extra black wire, and it used to go to a small chip that was there. That small chip, I couldn't find a data sheet that I thought matched it correctly, but my thoughts were that it was a logic level converter, and I think that's what these ones over here are being used for, but I can't say for certain. I'm sure if I trace it out, I can figure it out, but so far I have what I need, so I'm not going to spend more time than necessary trying to decipher it. So, we go back to here. The other thing I had done in the last stream was I had made this note, um, which um, broke out those wires that were going to the NPN drivers for the relays. And I realized that a lot of the signals were being doubled up, and I managed to find out which ones are relevant for my use. So, output 1 is actually the lux signal. To name lock. Output 2 is unlock. So when the unlock button is hit on the key, or if the key comes within range, it sends a pulse out on the lock or unlock wire. You can do it either automatically or through you pushing the button on the key. Pin 3. Output 3 is the trunk. So in the lock state, if you hold down the unlock button after a period of like 5 seconds or something, it will activate this output, which is for a trunk release. Output 4 is for the horn, which I will be using as a remote way of activating some of the lighting. It will just count the number of pulses. Number 7, output 7, is the ignition. And then number 8 is the starter. So what ends up happening is if you're within range and you go to turn it on, but don't use the um, it's this one here, the brick. If you don't activate this pin, it will go into just standard accessory mode. So I'm using this starter one just to make sure that if the sequence in my coding ever goes wrong, it always has to see starter, then ignition to come up. And obviously ignition will stay on until you turn it off. But if it doesn't see starter firing on first, then it knows you've tried to put it in accessory mode and something went wrong somewhere, and it can let me know that I've made a mistake with my coding. Now, because I figured out this is 3.3 volts, I did probe a lot of these pins in operation. They're actually running closer to 5 volts, so I think it's 5 volt tolerant. But to be on the safe side, I'm going to use a logic level converter. And thankfully, I found a really nice design. I found this design from SparkFun. That uses an N-channel MOSFET. It is bidirectional. Don't really need the bidirectional functionality of it, but I do still need logic level conversion. So I will be using this circuit to add in that functionality. What I can do I think I'm going to break up these pins. Let's see. Maybe I'll just leave it. Yeah, I think I'll just leave it. The other pin I needed to account for. So I've got the brake, I've got the fuel, and there's one other pin I need to account for. Pin 20, I think it was? Nope, pin 20 is the fuel, which I can connect directly to 3.3 volts. What I can do here is delete and simply leave a note for myself. Try the grid back on. Which eliminates these components. Oh, let's go back to the view. Sorry. So that takes care of that fuel wire. Now the brake will have a logic level converter, because that one I am controlling. You have to control that one, otherwise it won't shut off properly. Because if I left it always connected and you go to hit the button to turn it on and off, it will not work. And then on off is the other one that will have a logic level converter. Put 5 and output 10. I don't think I'm using either one of them. Not. But closer. Okay. So let's design the pull up and pull down. Let's see if I have this part natively. Don't, but I can solve that. So you can create custom parts in Eagle, but I found this, I think I found it through Mouser. They have this tool built in. So I have the library running on my desktop. And then I can go in and search for a part. 138. Let me go here. And it indeed does have the part available to me. So, download, and it should automatically install it, and it did. So now I can go back to Eagle, close that, and I'm just going to go into libraries, and it falls into this library here, and I can go update, and it should become available to me. Out, scroll down, I could probably search it, but I'm just going to scroll, and here we are. There we go, and that's the part I want. So, along the schematic, we copy resistors here and here. Connect that to there, this to there, and that to there. So I'm actually going to switch this out to 5 volts, 5 volt input, VDD, that's correct. No, it has to remain volts. The reason it has to remain 12 volts is because the antenna driver requires 12 volts. So there's actually going to have to be more than one power rectification. But the Arduino that's going to interface with this will have a 5 volt signal. So I will simply name it 5 volts, 5 volt. Let's put it on flag. Okay, 5 volt, and this one is VDD. VDD, which connects at 23.3 volts. And then I can simply have my connections. Name is going to be the break input. Actually, space it out. It's a little easier to read. And pin 4. That will eliminate this group. Now, I do need a second copy of that. Select it and copy. Now, I go edit the name of it. Oop. So this input is going to be here. Only that segment gets changed, and then the other one is on off. And then pin 4, I'm going to change it to break. Now, there's only 2 connections of that, and I want them to both be the same, so click signal. That corrects those. Not that should be all the connections I need. Let's see, max 6. Let's search this. Let's see. How about voltage? So I need a 3.3 volt regulator. Let's go SMD. Large modification. We get better. Output to 100 milliamps. That's more than enough. Data sheet. But I think that is going to be the one I'm looking for. So we will replace it. Nope. And I should make sure the ground is actually connected. Yes. Well, let's start by deleting that. Nope. Okay. Plate. And reopen it. Report. Okay. Now 7, 8. L 1, 2, F. I'm just pulling up the schematic for that chip. I want to make sure I'm using the right one. Output current 100 milliamp, no external components. Still gonna have capacitors. Let's see. I don't think it goes in a low enough voltage. Yeah, okay, so the one currently selected in the schematic is the 12-volt one, which is not the right one. So, I'm going to keep going. LM340. LM340. Nope, wrong search. I want to do a Google search. LM340. It's rated for 1.5 amps. Way too much. It's a deep pack. Two, two, three. Here we go. 3.3 volts, 150 milliamps. Okay, this is what we want here. And this is the common one found on Arduino boards existingly. So, maybe. So, the one I've selected. I wanted the 3.3 volt one. There we go. Let's delete that. It's got a few more wires than the previous. So, again. So let's confirm what this chip is. Mic 520. Mic 520. And pull up the data sheet. Okay, so I'm gonna take a bathroom break and be right back. Okay, I'm back. So what I'm actually doing is I wanted to double check the wiring for this, so I've pulled up the spec sheet for it. And it gives you two operations. I currently have issues on my bike with power. So to make sure that doesn't happen, I am definitely going to use the low noise operation. So, which interestingly enough, the original setup has this capacitor in place. Cool. So I'm still going to leave that output capacitor. That is not an SMD capacitor, that is a much larger capacitor. And the input has it too. Or at least has an input capacitor. The other thing I want to know is the label. So input, go straight in. Output, go out to there. Now this is going to have to go and get one of these SMD capacitors. Copy this in, and we're going to set value of 2.2, and it too goes to go. Let's go back to here. So, what I've done is input comes in, and it's going across, and I'm referencing the PDF to make sure that it goes in the right order. It's gonna annoy me that the capacitors numbers are going from C2 to C15. Now BP, it wants 470 picofarad capacitor. So I need to find out what's on the PF0603. Yep, okay, I can get that as a 603 capacitor. So, copy, oh no, copy that, and we change it, its value, 470 EP. And it goes to ground. So many of these going to ground. Let's do this. Split. Yeah. Let's try that again. Over, up, and over. And ground. Yeah. Let's just do this. Now, the enable pin is what I really want to know. Enable. Logic low open equals shutdown. Okay, so enable is going to input. Okay, that's the power input. Well, the main power input. I have inputs for those, and I'm going to move this reset. Let's see. Let's double check. Okay, so I have a wire here. Name it. Reset. Input that goes to here. Those are inputs. Yes. Okay. But gonna move those to here. Copy that. Move it up. And we can do a line. And text. Inputs. Now, those are going to need pin. Well, this one already has a pin on it, which may change. May end up changing that pin. But in terms of this, I believe I have everything on it. The only other thing I'm going to do is to run once we do check for anything going anything with a fork or pull down resistor that I do not currently have accounted for in the drawing. So yes, there are pull-ups on this. Ooh, pull down on that one at least. So pin 1 has a pull down. $10K. Pin 2 has one. Pin 3's got one. 4, which is 60. Oh, 10K. Yeah. 65. Pin 6. Pin 6. So pin 6 has one as well. Yep. Yes. Emblems. It's very high resistance. Looks like they pulled up. Eight mega ohm. 8 mega ohm. Oh, 8.2. Okay, good to know. So, this pen, this pen, this pen, and this pen all have pull-down resistors. Copy, oh no, copy, K, 2, so they have 10K resistors, and we're going to copy the ground. 1, 2, these pens, both resistors on them as well. Oh, and I think pin 6 had one as well. Last thing I want is something not to function right because I left a pin floating. Anti-tamper button, I bet you that one as well will also require pull up and pull down. Output, starter, those are outputs, 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 those are inputs, which because of the logic level converter will have pull up. I'll be pulling them down with the Arduino, so hopefully it should work. Yeah. I'm gonna error that will work. Yeah, okay. Let's turn off that. So, resistors. Copy. Place, and they are 8.2 mega ohms. Sorry. 8.2 mega, yes. And they go to VDD. VDD. Yes. It doesn't need to be that big of a label. Okay. That is the main assembly. Let's just neaten this up a little bit. Well, if I've connected them across, don't need this second signal. Anti-tamper button. That's the other one I want to double check. The anti-tamper button is actually a button input, and it would be, you would typically put it on a door, so if the door was open without the key, it sets off the alarm on here. That is pin 22, so 6, 27, 28, 29, 30. What? Oh, sorry, 15. 16, 15. Right after VDD. Okay. It's very high resistance. It's probably got a voltage divider. I'm gonna set that to 10K. Because I'm not going to be using it. It only needs to not be floating. I'm gonna leave the label there. No, I don't need the label at all. I'm not using it. Ground to the center. I can move this over. Things look a little nicer. There we go. Just using up a little less space. Now the only thing I need are the pins. So, let's see. I think it's 6 outputs. 1, 2, 3, 4, 5, 6. 6 output pins, and we're gonna have 1, 2. How does this reset button work? Is it pulling to ground? No, it's pulled low, so it's got an active high. Filter. It's got an active high, I think. Video driver. Capacitor on VDD. Antenna drivers inputs. Input, break input. This one. It is pulled low, so it's got to be pulled high to activate it. Let's swap it for this. And then I can add to my code to simply have it I'd have to go into my code, re-upload it, and tell it that I want to authenticate a new key. I think that's what it's for. I should really stop saying I think that's what it's for and actually read the manual. Oh goodness. Oh, okay. It's if the key is lost, you can unlock the door, which unlocking your door would trigger the alarm because you'd have it hooked up to the button. And then you push the reset switch for 5 seconds, disarms the system, and you can now start the car. Eesh. That's not a very secure thing. Oh, you can even use that button to start the car. And then programming method. Keep pressing the program switch for 10 seconds till the turn signal light keeps lighting on, then release it, and the signal light will keep on at the time. Press any button on the key fob once. Siren beeps twice at the same time. This means the first key is, has been programmed. Programming on it and repeat same operation for the other fob. The alarm can be programmed for 4 keys maximum. There's no programming for 3 seconds, twice exits. And the siren beeps once and the turn signal turns off. The key fob included is already programmed. If that's the case, then I should probably break out output 6, output 9, 10, and 5. So I need to find out which output goes to turn signals. I already have access to the horn signal, but I would need to know the brake signal. But so reset button. So name, reset button, connect, reset. Now, I don't know if this would work, because I'd always have to have it low. I'll give it a bit of try. If I find the circuit doesn't work, I can always troubleshoot, try to fix it. Oops, no, I want to move that. Okay. Now, turn signals, trace the multimeter, trace them back. I actually have a spreadsheet that I had made when I first started trying to decipher the key codes. So, originally I thought there were 14 wires turns out a bunch of them repeat themselves. What do you know? So if I look at the ones that I've actually used, I should be able to fact trace which ones are for which. Okay, so I'm backwards here. Horn, and then the one after horn, I don't use it, and I never figured out what it was actually for. I think it was like always on, and it just didn't do anything. And then 3 and 5, these two bits. That's why I never figured out what they were. It's because they are repeating number 3, which is your trunk, and also repeating bit 5, which I had no clue what that was. And then the ones after that, so 6 is just getting repeated twice. It's actually one signal, and that is the signal line. So number 6 is the one I would need to know, because as soon as that comes on, that would let me know that I can do a reprogram, should I ever have to. But don't expect to, but never hurts to put the functionality in place. Especially because this board is going to be custom. Never hurts to put the functionality in place now than to not do it and regret it later. Output 6. Signal lamp. Name. Lamp. Yeah. So I got input 1, 2, 3, 3 inputs, and how many outputs am I putting on here? Let's dip by notepad, make some notes. So terms, inputs, we have reset, we have the key, and break. Those are my inputs, and then my outputs. Let's see here. Output. Trunk. Lamp. Horn. Lock. Unlock. Accessory. And well, ignition. GN. And starter. 1, 2, 3, 4, 5, 6, 7. And it needs 5 volts. So 8 to operate. So we can get a add part, header. We need a alright, that's SMD. Now let's go through hole. 1.1, 2, that's 3. Yeah, let's go that. Actually, because I know I'm going to need an 8-pin header, I want them to be matching. because I'm particular that way. Let's make sure I can get any pin header in the format that I want. New, big, yeah, okay. That's circular. This isn't circular. That's annoying. Not that I truly expect circular versus a hexagon solder pad is gonna make that much of a difference. I'm gonna be particular about it. That's 90 degree. No, I don't want those pads. I hate those pads. These pads are good if I want like big wires attached to it. I want to put a lot of solder in there. But I don't. Probably gonna use a pin header, like the one shown. So 80-foot pads it is. Nope. Okay. And that. And we can label them. Reset input. Quick input. Oh, no. Let's fix that. Space. Yes. And key input. Connect. Okay, that's my input. And my output. So we have our MCU. We can move that. Draw a line around it all. We want a nice fancy. And I'll probably put my outputs up here. So, text, micro, and the outputs are going to be this. And then we'll have I think I'm just going to use a 3-pin just to keep it easier. Net. I'm likely going to make this board nest, so the main computer on this is actually going to manage my 12-volt system as well. And I've started some of that design. So 12-volt battery management system. I've started some of that design as well. So it has the ability to watch how much power is coming in and going out, obviously, and shutting it off so that power can't flow in or out. And then it also has the ability to manage each cell for balancing, and so it can manage the solar, because I want to try out solar and I want to be able to data log it, so I might have an SD card reader on it as well, and all sorts of stuff, and I'll probably have an LCD screen or something on the bike where I can view it all, maybe look at Bluetooth or something. And all of it can be available to view. And so I've started this design, and what likely will happen is this board will nest on top of it. Instead of adding wires or anything, I can just nest them onto each other, in which case adding the 3-pin and 3-pin and then the 8-pin on one side means I could use it to level itself and not have to worry about, similar to an Arduino shield, where there's pins on both sides of it and they nest really nicely. I may end up doing that as well on this, so that I'm not worried about them coming apart or anything. Not that it's going to come apart, I'm not going to use headers like an Arduino, I'm just going to solder both ends of it. Name. So that's that. And then now I need the outputs. Lock. Lock. Front. One. Connect. Yes. Ignition. Starter. And lamp, and then 5 volts. I'm just going to pass up 5 volts from the dotted board. And that should connect everything. And that makes up the entirety of the board. So, save that, and I believe I've noted everything, which means we can start the actual board design. So, like I was saying, I'm thinking we keep pins on both sides of it. It will allow the board to sit really nicely. Capacitors. Crystal. So want to try and mimic how they set the components on this board for the radio antenna. For right now, I might just turn off the rat's nesting. Let's turn that on. Let's set it to millimeters and 0.5. Actually, let's just set it to 1 right now, and I can refine it later. Typically, I try to go fairly small. I try to make it compact if I can get away with it. I've made a few recent board designs recently that got really small, a lot smaller than I thought I could get them. So, if I mimic how the board set this up, those crystals really are close, and it gets a bunch of passes. I'm going to need to turn the nesting back on, because, actually, I just prefer to set schematic. So all these are nested right next to it. Let's turn that back off. So, capacitor, resistor 11. Can I do a split screen with this? That's not better. Resistor 11 is 75 kiloohms, and it goes right next to this pin, and then capacitors C5, C6, C7, C8. 5, 6, 7, and 8. Down a bit. I will probably make this far more compact, but for now, I'll leave it like that. On the other side, we have C9 and C10. C9, ground, data out, connect there, and then C10, which actually uses the ground plane to connect it to. And there are 2 board pins on this chip that are left not used. And I'm just going to make sure that they are indeed not connected to anything. Connect it there. Oh yeah, let's go ground on it. So select 0 does indeed connect to something. It's got about 4 mega ohms of resistance on it. So what, it doesn't look like there's anything connected to it unless it's under the board. Under the chip, I should say. Because there's definitely no via underneath it. So I'm wondering if it's internal. Yeah. So as far as I can tell, it's either internal or nothing connected to it. Because it shows up as 4 mega ohms both to power and ground. Okay, that's that. The antenna outputs. Now, how do I want to do this? So the way crystal and antenna are set up, the antenna signal comes out here, and it goes to capacitor 11, 12, 13, 14. 11. So 11 goes here. 12, 13, and 14. And then from there it goes to the antenna. And I'm going to try and fit that there. Which means let's try and fit that antenna there. This antenna here. And then the drivers, 4 set antennas. Be here. Because I have the routing turned off, just so I'm not looking at a mess of wires going all over the place, making it hard to see. I don't actually know the position of these chips just yet. But we and still place them. So that's that one. Now this is the one we're doing right now. And the one thing I'm realizing right now, in this, let's save this. Save. We're missing capacitors. So, copy. I don't think there's any capacitors on the output. It was simply the input that should have capacitors. Step 2. 1, I think. 1 per each. Okay. Save, and we can go back. So those capacitors are C3 and C4. Goes with that chip, and this one goes with this chip. And from there we have the 1 kilo ohm resistor, so R1 and R2, 1. Two, that one goes to IC1. Yeah, IC1. Okay. I think the next thing is the power input. JP3 is my power input. It is. So power comes in, goes through said diode, and from the diode goes to a capacitor, and from there goes to our regulator. From the regulator comes out to C15. No, there's R. C15. There we go. C15 and C16. Snap those to the grid. And we come out to this capacitor. And so that is the power input stage. And now, these are the inputs which have the logic level converters. I did test it, and it does. The chip seems to be tolerant to 5-volt inputs. You can. Some of them have resistor dividers for their input, and that's it. And even when you do the math, it's upwards of close to 6 volts that some of these pins might get. But I want to play it on the side of caution, so I'm going to have uh, these logic level converters in place. And I really do hope this circuit works for this purpose. Downside to this is you can't get more of the controllers. Well, you can, but you gotta spend like $70 for it. If I wanted to keep testing this and keep reheating and reflowing that chip, it's would get expensive very quickly if it didn't work. You blow it up. Well, if you blow it up, you have to I'd have to go through and find every component and follow every trace and make sure that I don't miss something. So, and then it's got a bunch of 10K resistors following around. 13, 14. So 13. 14. That is Q3 that's supposed to be with. 13, 14 go with Q3. Q2 is 6 and 16. 6 and 16. Or 6 and 6, 16, and Q4 is 24 and 25. 24 from there, and number 25. Yeah. Snap them to the grid, and then there you go to that. Might just start with that, and then do the main controller. Go get into some sub-assemblies, but the goal would be to fit the microcontroller in here. Yeah, thinking that's what I'm gonna have to do. Just so I can try and keep it somewhat compact. Let's turn this on. And that's nested. VDD, VDD. Yeah, let's try rotating that like that. Ground can connect across like so. VDD comes across like so. Ground will be ripped back up and turned into a ground plane. But for now, so that I can route everything correctly, relevant to have these names everywhere. I'm going to leave the resistor value. That's employees. And then that goes up to the ground plane. And I'm laying these capacitors out in the same way that the board is laid out. So this is the chip here that I'm currently working on in the PCB. So those are the ones that I'm currently designing in Eagle, and I'm matching the um, the layout of all the capacitors and everything. I'm trying to do this so that the boards match in some sense of the terms, and so in most ways they will match, and thus I'm hoping we'll cut down on any potential failures. So and group these together, move them as one. Signal comes in, connects to there, and that goes to ground, and the antenna connects to there, the antenna comes out. Okay. That's the circuit for that. Think I can come in a little closer? Yeah, I can get away with it. Let's delete that and those. Check the circuit here. Pass. Handy dandy magnifying glass. Wondering. Yeah, so signal comes in. This needs to be changed. So I'm going to rip up that. We're going to rotate these parts. That is how it wants the signal connected through those capacitors. And big ground plane surrounding it all. Come to the input, put to there. That can connect across, that can go to ground. Nice. I think my design tools are set with about 6 mil, 8 mil clearance, which I think is the standard for most PCB houses without paying extra. Let's find out. Give us some clearance. 6 mil is what I have it set to. So anything closer than that and it will let me know. VDD comes out, this comes out, which means we can rotate this capacitor. I want to leave the capacitance value. See, it's noting that the air wire, or the PCB trace, air wire is the yellow wire, PCB trace that I've placed is now too close to the pad because I rotated the part. We can delete the C designation, I don't need that anymore. I want to leave the capacitance values in place. And we can make that closer together. Trying to set these up so that they'll be super compact. Less board space, that kind of stuff. We can also delete that capacitor designation. Leave the values in place. Connect everything else. And I can disconnect these grounds. Ground, ground. Connect voltage. Before it comes in. Now, we do need 12 volts to drive these antennas. And these antennas are not driven through this circuit, so they're not as susceptible to issues. They do I want to run it all the way around the board? I'm not sure. We can rotate these. And what I'm realizing is the antennas are swapped. Hmm. That can go like that. Leave those resistor values. Let's check the schematic and see what's going on here. Oh, in A and B are connected. Okay. Well, let's go underneath it then. trying to make it accessible for the ground to get to a ground plane very easily without having to put vias everywhere. Still feel like I'm waking up a little bit. My goodness. Volt comes in, comes across. I'm going to connect both 12 volts to each other. And from there it goes to the antennas. Now, from what I understand, it's actually it's not just turning them on and off to create the 125 kilohertz signal. I believe it's doing a pattern as well, because the keys only wake up to this module. So I believe it's a very specific pattern as well. Similar to shopping carts. Shopping carts use a similar mechanism for those anti-theft wheels. There's a loop built into the property edge line, typically near an entrance, and it's a very specific pattern that would trigger those locks. But they do have a backup receiver in them for unlocking and checking data and stuff like that on them. Surprisingly complex in their electronics. There's a YouTube channel that did a teardown on it. I think it was EEV blog. Could be wrong on that. Now this is a mess. Okay. Let's have some fun over here. Get rid of that. Get rid of that designator. Get rid of that designator. That one. That one. That one. That one. That. And that. And let's figure out where they all go. 10K goes across there. Reset input. Did I not add? Oh. Gotta double check the spelling. Name. I'll fix that. It's going to confirm that I want it there. Yes. Save so I don't lose my progress. Save. There we go. Okay. So, now, I'm realizing this entire circuit is upside down. Okay. Goes to there. You go to there. That takes care of all those. I may actually end up using the auto router for some of it. And there's a mess of everything all over the place. 10K, 10K. Don't need that all over there. Oh, I only really need one, but I'll leave it for now. They're all 10K resistors there. And now I can place the main trigger port. I'm gonna get rid of that designator and just leave that one. And the fun task of trying to align everything. And I'm likely going to move around these pins to try and make it a little easier. So that 5-volt signal needs to come all the way around there. So I'm likely going to leave that in that position, but these will probably get swapped around to make for an easier transition. What is transition? Maybe leave it like that. Disconnect over here. Okay. A. And I'm gonna get rid of those designators because they are absolutely massive and they're annoying to look at. There we go. A and B. And we're gonna need, let's go back to that. Split the screen. And let's see where everything goes. So, look at our schematic. R3 and R5. R3. R5. Then go to a R4. R4 is what connects it to pad A, which then pulls them to ground. So, nope. No, I didn't want to delete that. No. Delete that. Delete. And yes. Can move that around. 2. 10K. There we go. And we're going to snap these to the grid. This can be simply looping to ground. So I have no problem leaving them next to each other. And now the next pins, 15, 16. Excellent. Put that over there. We can get rid of 22 and 21. And next to each other. And then a bunch of these pins are simply being pulled low. What's this 300k resistor for? So, I missed one. This 300k is part of this circuit. It's part of that circuit. Leave that there. While I'm using a very small trace right now, I will actually go back through likely, and I try to use the biggest trace for things that I can possibly get away with in whatever size constraint I've decided for a PCB. Sometimes I'm building it to fit into something existing and I want it as small as possible. In this case, I kind of want it as small as possible. I haven't really designed the trike itself yet, because I have an idea in my head. Problem is with a trike is you need right proportions between how the seat fits and how the um, what do you call it? The pedals. And right now it's not set up very well on my trike, so my feet do end up hurting after a little while, and butt hurts after a while. So it's not the optimal right now. And unfortunately, there's really no space for me to actually adjust that. So the next one, I'm going to spend time adjusting that so that it's nice. And so I have the idea in my head. I'm probably going to make it out of lumber first, where I can cut pieces, glue them, nail them together, retry it, build it up. Once I have a reason for lumber is it's a heck of a lot cheaper than the aluminum's going to be, and then I can use construction paper to wrap it, essentially, to make sure it's not too claustrophobic when it's going to have cladding on it and the canopy. From there, I can take measurements from it, put it into my CAD modeling, and make the design. And then I can take these circuit boards, I can take the size of the battery pack and everything, and input it so that I can have tie downs for everything. I can make mounting points for everything, so that everything has its spot and is nicely organized. And I can make a really nice wiring loom to go all over everything and keep everything the way it should be, and avoid a lot of the issues, hopefully, that I had on the last one. Now, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 resistors left. Okay, let's full screen that. And the other thing I try to do with a lot of my designs, because I got a soldering oven, is I try to keep all the SMD stuff on at least one side of the board. Unless it's like some of those massive resistors, like the 2512s, which are 1 watt SMD resistors, then I may put stuff like that size on the back. Um, that way, because I can solder those by hand. Just to cut cost on getting lots of stencils. If I don't have to pay double for back and front stencil, it's kind of nice. And sure, no, that goes to that pin. Let's go into that pin. And what I'm realizing right now is this might make the routing a little tedious in order to get the lock and unlock signals where I want them to be. What I am thinking is if I move that inbound and I can run the trace under the controller. Let's clean up these so that no. Nope. That one. That one. That one. And that one. These are all actually 10K resistors, so I'll probably end up deleting some of the silk screen for it. So that can go like that. I can go right next to it. I can also go next to it. Nope, that's the second one. That can go inbound. So I can probably split the difference on that. Nope, these two gotta be switched. And let's get rid of the silk screen here. And from there, let's move that one. And then that should hopefully give space to go around it to connect. And what I'm probably able to do, this 125 kilohertz signal has to go all the way around. That is very annoying. Hmm. 125 kilohertz, I'm probably going to pass it on the board then, through via. Yeah, so that's kind of perfect. Connect. Yeah, let's leave that where it was. Now, the output signals I probably could pass under as well. Those can connect together, and realizing I can take it out here. And lock it. So the data from the receiver, I'm going to pass there. Lock, put there. Unlock, put there. Ignition starter, output 9. I'm worried about it. But I'm going to have to move some of these around. Unlock, ignition, and so what order should I be putting it in? So, lock, unlock are fine where they are. Then it should be ignition. I'm writing down on a note for when I go back to the schematic view and I can change the labels around. Starter. The 125 kilohertz I'm going to pass under the cord. Which I'm realizing now may not actually be the best way to do it. Oh, no, it might still work. Oh, this is going to be a fun one. Let's see here. Let's switch the items that I wanted to switch. And then it's definitely gonna have to play around with the wiring here. Most of the boards I do are exclusively 2-layer. I've played around with 4-layer, but the extra cost, and if I can get away with it, I am going to find a way to make it 2 layers. Trunk 1. And again, and might as well name. So IGM connect and sure to save. Okay, and so I'm wondering if so what's going on in my head right now is I'm wondering if I can pass these signals through here. Although the reason I was thinking it wouldn't work here is because you'd have stuff in the way, but I'm realizing I don't actually have stuff in the way. I was reading way too far into it. But nonetheless, I still have to run these wires. And let's go to the underside view. What's the size of the board right now? It's about 68, 63, so I'm definitely going to be able to shrink this down a lot. And those measurements are in millimeters. But it definitely looks like I will be able to shrink down the size of the board a lot. How was it connected? Yeah, so this is part of what I was worried about. This ground plane. And I still have these three to connect. Um, And then the other problem is I still have these signals as well. The on-off break and reset have to connect to the logic level converters. They can be on VS. They won't be an issue that way, but I do... Actually, all these signals could be on VS. It's not really an issue. They're not flowing much current. And then it goes trunk. Trunk lamp horn. Nope, this is what I need. Name trunk lamp horn. Connect. That is the nope. Actually, I'm gonna save that first and go back in here. And now I should be able to run the necessary traces. Now right now the grid is set to 1 millimeter, So it's quite a distance apart, which means a lot of this will be able to be made a multitude of times smaller. That is everything connected, which is very nice indeed. So I'm realizing we can move things down in preparation for making things compact. Um, I'm going to delete that designator, but keep this one. This designator can go. But I can keep this. The data. I want to try and fit a ground plane to come in behind here and wrap around. Round. Yeah, it's gonna have to come under. Actually, it's gonna have to come through here to each of these pads to see how that works out. Ground plane. The antennas are in place. Power circuit. Okay, it looks like I have most of it intact. I just have to make it compact. Okay, let's change the measurements. Mil spec. So I could go pretty small on that. Holy cat. Wow. It's all in place nicely. That's in place. Try and move things so they're all nice and compact. We like compact. Well, I like saving space if I can. I'm actually going to move that over so that I can get a bigger trace in there. Not that I really needs it. There's very lot of power on it, but it couldn't hurt. Let's give it a bit of space for digital wire. I could lay these traces on top of each other, but I would worry about potential capacitance between it. So, just to be on the safe side, it is easier to leave them separated. Does look like I'm going to be able to move this down more, which is nice. Compact is good. Yeah, I can remove that designation, remove that designation. It's gonna be let's rip up these. And let's move this board down so that hopefully this can all fit. What height do we have this at? Let's go back to millimeters. That puts us at 50mm board. That'll be fine. 50mm by 50mm. It's a fairly nice size board, if I do say so myself. I try to keep all my boards 100 by 100 or under, as that's typically the price point for a lot of the online manufacturers, where you get a really good price, like 5 boards for $5 or something. I don't think it's $5 anymore, but that's typically the break point on them. to mill. Just make sure that my spec is right. Didn't seem to change it. Sometimes the decimal point can change issues, but it looks like 10 mil is an ideal spot to be. Ground is going to be underneath this trace, or underneath the chip through the ground plane. Let's rip some of this up because it's going to annoy me. There we go. Which probably means I can move a lot of that down. 15 millimeters this way. Let's see. Line. Dimensional. 0. And on the 50 mark. 1. 60. 50. It's over here. Okay. That's 50 by 50. That is 50 by 50. Grid 0.254. Okay. Delete. So let's see if we can't squish all the parts in. So these parts are too close. So we can fix that. And I'm going to rip up that because I think I can get it further down, at least further across. Rip up, signal, rip up, signal, rip up, signal, rip up, signal. And let's go from there. I want to see if we can't get these antennas right smack over here. See if we can't push some of this stuff over. And um, hmm. So definitely need to move these over. And looks like I'm gonna be ripping up some signals. And that's spaced. These. And yes, I am backtracking a lot on this design to try and squeeze it in. I probably should have started with setting a board size. It would have been maybe a little easier, a little faster than trying to backtrack and remove a lot of this. I thought I had it optimally laid out, but I was way too far to one side to try and squeeze everything. And yes, I am leaving a fair amount of space here. And the reason I'm leaving that space there is I want to fit a nice big ground plane in there as much as I can for that in time. Everything else should be able to go in nicely once I'm able to accommodate everything. And because pen 1 isn't used, I'm going to move it over this way more. Um, the other hard wire to get through is going to be this 5-volt wire, which I might use this second pin for. It might be easier to use the pin over here than it is to use this pin over here. Or use the input pin for it. Nope, no. That wants to move the yeah, that. Yeah, okay. So what we're gonna do is we're gonna move this 5 volt from there. We're gonna replace it. Nope. Wrong one. Place it with a 7 pin? Do we not have 7 pins? 6 and 8. Yeah, okay. Never mind. I will leave it as an 8-pin and instead go over here and replace this as a 4-pin. Nope, that's 6. Should have a library called header. Do I have 7? Yeah, it's that style. I don't like the info. That's a nice style. There we go. Really? Okay. Let's add it separately then. And then swap this one out as well. Add part, 7-pin. And I've directly connected it so that what I can do is I can actually delete this connector. I'll find out where it's connected. There. I'll do the same to this one. There we go. I had to find where its delete connection was. Like, if you're ever designing custom parts, please don't do this. Don't put the connection point right where someone wants to reach it. Like, that is super annoying. I think that's a bad design thing. Like, don't do that. That's like in auto mechanics. There's an engine where the starter is underneath the intake assembly, so you have to take the whole top of the engine apart to get to the starter motor. Don't do stuff like that. Like, if you're an engineer, like, don't do that. Like, that's the one thing I like with this hobby, is that I am the engineer. I am designing my product, and I am going from an idea or a design. In this case, I'm obviously taking something and remaking it to work for my application, but I'm making the design and then in turn um, making the physical product. And if it breaks, I have to be able to fix it, or I have to keep working on it, or I have to make improvements. So it forces me to make sure that I'm doing something that's appropriate. And I know some of the colleges and universities near me have started doing that with some of their engineering departments, where they'll incorporate shop classes into the curriculum to kind of force students to realize just because you can design it doesn't mean you can make it, or make it at a cost point that any company is going to want to do it at. Now that those are replaced, I should be able to go back into here. Let's save that before we lose it. Save that. Back into here. Probably going to swap these antenna ones out as well. It's the same size, only slightly larger, which will make for easier soldering. These ones are actually fairly difficult. A little difficult to get the soldering tip in there. Now, it should make easier setup. That's connected to there. VDD comes into there. And we're left with setting up final pins. Now 12 volt is going to need to come over here, and it's all the way over there, so I'm likely going to go underneath the board and make a track for it. So with the on-off inputs, I just feel like you could make this more compact in a way. 50 by 50 millimeters is more than enough for my application. It's not too small, it's not too large. I'll have the room necessary to move things, to work with it and do the soldering without too much difficulty. Rip up. Now, because both of these are the same, I'm going to remove that silk screen, but keep this silk screen in place. And that there. Those are going to connect like that. VDD. How did I want to connect VDD? That's a good question. Let's move this. Can get fairly close, or probably move it like that, and by putting it like that, get those wires up and out. Because see, these are surface mount components, so I can leave the traces on top and put these traces underneath. Okay. And what I'm gonna do is swap over to mill and set the wire trace. Sex. Oof. Yeah, no kidding. No. Go thicker than that. Let's go 16. Yeah, okay. So 16 seems to be the largest I'm gonna get away with on these pads. So let's see if I can't design with 16 as my trace. On off. There, break signal. Top to there. Reset button. That gets those traces. That's that trace. Oh, somebody posted a good question on the Discord for Superhouse. Default always on, but turn off when triggered. Use an N-channel MOSFET, but instead of a pull down, use a pull up. MOSFET is now always on. Then add a button to that pin to ground, which and I can actually make a quick schematic. So the person asked on a Discord server for Superhouse TV that I follow about cycling power. So I'm going to create a quick sketch, and I figured I'm already live streaming. I might as well show how something like this would be done. So N-channel MOSFET, 1, 2, 3, arrow goes in, the line, I think I'm drawing it right. Let's double check. Yeah, okay, I'm drawing it right. Actually, instead of doing it like that, let's just set it up as kind of like a black box. So you have gate, train, source. I definitely don't need the text that large. Gate, train, source. Gate. Train. Source. So normally your gate would be tied to ground. So instead, we would tie it positive. Volt or 3.3 volts, depending on what you're running on. Resistor, 10K. And go here, and you tie switch to ground. And yes, I could make this circuit in Eagle and all that stuff, but I don't really want to close my program. I can very, very quickly do it in here as well. So source, tie that to ground as well. And This goes to the Arduino ground. Crop, and I'll save that. Okay, so I'm just going to save that off screen, and okay. Now back to my actual project. Gotta chase that squirrel. Squirrel, squirrel, squirrel. Find. See, the one thing I'm wondering is if I can get. See, I definitely put around here as a via, and then trunk and else. And come through here, I think. Which case, let's move some pieces over. And I'll have to reorganize these, but that looks like it will work. Let's rip up this signal here. And that's annoying. Let's leave it for now. VDD has to come out. VDD, double connected. Now it's not actually double connected. One of those is considered a fuel pump wire, and it needs to see positive power in order to not keep trying to click the starter relay. Although I think I tested it on mine and it didn't do it, so I don't know. I'm just gonna leave it connected because it doesn't hurt if I leave it either way. Anti-tamper button is not being used in this design, so it has to be pulled down. Input 9 is not being used. This one can go there. This one can go there. 125 kilohertz is going underneath the board. I'm gonna leave that for now. Let's switch back to top layer, starter. Goes to there. Ignition. Now the lock and unlock wires. I'm gonna have to go underneath. Lock and unlock, and back to there. There. Not gonna be able to pass VDD through there. Because I kind of want the ground plane to go around this trace. Right. That's fine. That's fine. That works. That works. That's connected. It's not connected. It's connected. Let's try to open these up. So this signal, I'm going to make it much larger. Um, let's move this down. I'm trying to make space so that when the ground plane comes in, it's got somewhere to go. Hopefully. I'm hoping that I can use a ground plane there. Something. Switch that up. Switch that up. And let's do this. Go. There. Boom, 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 boom. That's connected. That's connected. Let's fix up some of these traces. I'm realizing if I move it up, I can create a bit more space for myself. And let's rip it up. Rip up, rip up, rip up. Probably should just rip up signal. Signal, rip up, signal, rip up, signal, and this one. I don't want to redo everything I've done all the way over there. So, and I hate if you don't hit it exactly on, Eagle likes to ping at you. It's like, I know I didn't hit it, I can see that I haven't hit it. Still has to remind you and give you the warning bell anyways. The one thing I had noticed is one of these wires didn't connect correctly. And the bolts comes around, goes to there, comes through to here. And VDD comes around, goes to there. Route the wire there, to there, to there, to there. There, to there. Okay. Those are those wires. I convert that and that. Crown is there. And I'm getting close. Woohoo! Yeah. Bottle of root beer is empty. Nice tea it is. Now what I'm realizing is I wanted this to hopefully hit the ground plane, and why I was putting the beer there to pass it to the bottom. I'm realizing, yeah, that's got space for the ground plane. Oh, push these wires closer. Giving space for the ground plane. Okay. It's all nicely spaced. And let's fix this one. There. Nicely spaced. The ground plane can come in and connect. And we're left with the 125 kilohertz signal, which is going to pass underneath and connecting trunk, coil, and lamp. Lamp can stay the same. One and trunk can be switched. So going to the outputs, trunk and horn, and we're going to swap it for trunk and horn. That should be those outputs, and we can go back and finish connections here. Now that's going to leave those open, and that's annoying. Let's use vias. I have the ability to do so. Why not? Use a via. How did that connect? Oh, let's fix that. Save. There we go. And now all these will have a ground plane on them. So that ground there can have a ground plane, that can go to ground plane to there, I think. Yeah, because the ground isn't going to have to come around here. Which means it's going to come around there. Let's move these over. No. Good, dang it. Keeps thinking I want to move something else. There we go. Let's move this over. And that way, what will happen is ground will connect here, ground will come around to there, connect all of that, ground plane comes around it. I'm going to make the traces larger for the crystal. Not that they have to really be this large, but I'm going to do it anyways. Although they are kind of large on the port too. Yeah, definitely not this large though. But I'll do it anyways, because I can. Angle that, because you want angles and not super straight lines when this gets etched. And the other one I want to fix is this digital line, which is the signal for the radio. I'm tempted to tap into it with the Arduino as well. The Arduino can't read the key signal, even though it is the 433 megahertz. But it does pick up like generic key fob signals. And I can't immediately think of anything that I'd use, although I do other things with generic key fobs. I can't think of anything that I'm going to add to this particular trike that I'm going to want that generic key fob for. Everything kind of seems like it's going to be self-sufficient with the current architecture. And it's very tempting to add something there, because you could just run the wire right down to here. Yeah. Let's future-proof it. Let's do it. I really have nothing to lose on this one. Let's see here. We can move this up. And add part, and we can go in and select this one. There. And oh, nope. Come on. There. We add another net, and we can name it DO, digital out. That connects that output, and I should be able to take this and place it in nicely. And flip up that. Let's move this into place. Trying to leave space for the eventual ground loop, or ground plane that has to come through. That's not a nice setup there. So let's rip that up. Let's do this one first. That's those connected, and now I can merely take this signal and pass it down. Likely won't need that digital signal, but if anything comes up where I want to implement one of those remotes, well, I can do so. Now, I know I'm going to have an NOF attached to my trike. One is going to connect to a trailer mechanism, because I'm going to have at least two trailers. One's going to be a large solar trailer for long distance camping, stuff like that, long distance drives, because I want to do some of those. I've wanted to do that for a while, but one of the spots I want to go to, the longest leg is about 150 kilometers, so unless I drive super slow and conserve energy, it's not going to work. And the pedal ratio on my trike sucks. So that's something else I'm fixing on the next version, is how the pedals work. and yeah, so it's a matter of making sure that things work the way they need to. Now, because pins have to pass through, I am going to go back to the millimeter scale and place those in spots that are registerable, so that I can make sure that everything fits the way it's supposed to. Alright, the 125 kilohertz signal needs to be sent. Hello. Yeah. And that is everything. Ground plane can go in. Right, I also want to increase the size of this signal wire. There we go. Just to be sure. It's definitely overkill. And I'll leave it. Let's move that over a bit. VDD, I can come in, no problems. It's less than, this is only rated for 150 milliamps, so it's going to be less than that. Let's move the silk screen, and I think that's everything I need to worry about. 300K goes there. That can go like that. There. Go like that. I don't need both of them. Because I don't need both labeled. We can make that compact. This signal trace can come in. That. This signal trace can be beefed. That definitely doesn't need to be that large. I think I've covered my bases. Yeah, okay. So the only thing left is to put these pins in a good spot. And the reason for that is the main controller, which is going to be the battery management system on a 12-volt battery. That is going to be my hub. That will then control everything. It will turn power on and off everything. I'm going to use P-channel automotive high-side switching to make sure everything gets controlled the way it needs to be. And that will allow this module to sit on top of it. That module will very likely be a lot larger. So I want to make sure that I can have pins sit on top of it correctly. Which is why I will have to make sure everything gets labeled right. Mr. Wire over here. I really feel like I can make this smaller. Um, I'm tempted, because if I shift that down, can I move this power circuit somewhere? Hmm. Probably keep the power circuit on a different board, to be honest. Oh yeah, I still have to run a 12-volt wire over here. That's one of the big things. And it's gonna have to work its way around. And it's gonna have to come around here. Yeah, let's try moving this around. See if we can't make this compact. I almost wish Eagle had a built-in, like, let's see how small we can make this kind of function. But problem with that is either you'd have to just let it find the optimal way of placing it, which I don't think would be too hard to program, but that won't take into consideration if you have parts that want to be isolated in some sort of fashion. What I can do is I can move because I can move this up and over more. And I'll be able to move this down into here. That gets that extra small. Now, so ground doesn't have to come down here. It only has to come into here. And there. So you can do that. And actually, what I can do, similar to this, where it's coming out underneath it, I can pretty much swap everything around. I'll put 10. And then this can come on top of it. Two K can go over here. A and B. Now B doesn't actually get used in the current circuit board. I think the manual tells me what it is for, but I really don't need it. But I'm going to leave it there just in case. Okay. Yeah. So that'll allow ground plane to come in and go wherever it needs to. And it means I can shrink this circuit. Now, I think the reason the module has this big capacitor is because of the on-off. Feel like I can eliminate some of it, or at least cut it down. I want to keep the regulator for 3 volts. The main board will have 5 volt regulation for everything else. But thinking. Because if I keep just this, I could fit it in here. Make this board nice and small. Not that it already isn't small, but marginal. Um, Trying to think the best way of doing this. Because the spec sheet says it only needs this capacitor here and then this here for silent operation. And the only big inductive load is this. And it's powered off the 12 volts. And I can put bigger capacitors on the main board and keep this smaller. I already have 5 volts coming in. Um, so if I try this. Yeah, look how small I can make this. Look at that. Yeah, that'll work a lot better. Uh, yeah. Yeah, I think it will. Okay, let's go back into the schematic and remove a few parts. Connect. Delete. Save. Save. And let's change this to millimeters. 1 millimeter. And that is 36. Oh, can we get it down to 35? We can. Nice. And while I have it on this particular format, I'm going to mark these so that they're in a essential standard spot, so that when I do the board that it matches to, I have pins to follow. Although I'll very likely have to come back and make some changes. It's almost inevitable. It's to there, to there, to there. And we'll go back here and go to mail 10. It's too close to the edge there. Let's try and move it over. And hopefully, actually, realizing now, what I might be able to get away with is rotating these resistors. Which can give me the space I need. I'll probably, yeah, I'll still go underneath each leg, but it does give me the space I need to get closer to the, the edge. I'm just realizing my webcam is flipped as I'm trying to point. Let's group it and I'm going to move that there for now, just so out in my visual and annoy the heck out of me. So what we can do now is go under, up, under, up. I'm trying to see if I can't wire it down. Sound, but it seems like it's a Windows thing that it's triggering instead of the application making the sound, which is very annoying that I can't change it. There might be a preference setting as well that I can change, but I'll check that another day. Google it. Amazing the number of things that can be solved by Googling. People should do it more often. That's VDD. Now what I can do is take 12 volts and come out for this. Now that's annoying. It's probably the best way I'm going to route that. While maintaining a resemblance of a ground plane, which is why I did that. Put that there, like that. It's got 12 volts for it. I'm gonna swap this around so that it's easier for the ground plane. Because this capacitor also needs a ground signal. And I can connect that like that, that like that. Ground has an easy way to get around and connect everything. VDD comes around. Looks like I'm getting somewhere. With a much smaller circuit board too, my goodness. Actually, I want to compare. So this is the current circuit board. I kind of want to compare sizing. Let's take the micrometer. So the length of it is 80.5. And the main portion that's actually running everything is, let's use this end. That again. Both 35. So the fact that I've squeezed mine into a 35mm spot is about accurate to what the current board is in terms of where it's placing the circuit. Minus the fact that I'm losing some of the filtering capacitors. Although I am switching to a different regulator than this one is using, and my board is only 50 millimeters in terms of width, so that's 50 millimeters. So I'm cutting the board down quite significantly in size. So this board definitely cuts a lot of the size down, and so because this is a 12-volt signal and I've placed these in very specific coordinates that I will be able to allow it to connect like an Arduino shield to the main board that it's connected to, which is the 12-volt management system. Because of that, it means that I will be able to put capacitors there. And I will definitely be putting capacitors on that side, for the even just for the sole fact that I've had issues on my current bike with it trying to do power management, and I'm getting brownouts and other issues that I'm not enjoying one bit when my lights are flickering and they shouldn't be. I'm going to move these closer together so I don't have issues that I don't want. I'm going to move that up so that there's less potential interference with the output coming through the resistors. Move that up and away, so ground is going to come around here. It's going to fill in all this area, and it's going to be on both sides. And I'll probably plop a whack of via holes on both sides of it. At least that's what the current board has. Let's see, I don't think there's anything else I need to be critical of, other than these 3 signals. This via is causing it to go up, so I want it straight. There we go. And there we have it. We've managed to shrink the ever-loving crap out of this board. I'd prefer A and B to be a little closer together. There. I just think that will look nicer. Let's move it out a bit. There. Other than that, let's do a ground plane. Which I need to do a Google search for, because I don't do ground planes very often. Gone. Found. And let's do it for the bottom as well. Honestly, I could probably isolate a section of this. I'm wondering if I should isolate some of the 12 volt from the ground rail. I don't think it'll make much of a difference. We'll see how it turns out. Okay, rat's nest. And that's how the bottom ground looks. Let's go into DOC. Clearance. Same signals. Yeah, might just leave it the way it is. Check air wire. So, a few things are not connected correctly. So let's fix those. Let's turn off that and we can rip it up again. Let's fix those. Nope, wrong size. There we go. It's connected. Let's find the tools again. Check. Air wire. Yeah. Stop. Stop. Oh, I can see a few wires that are missing. There's a stub over here. Let's fix that wire. Nope, I had it set to 32, I think. There. Our stub over here. Let's fix this. That goes to there. And let's try that's nesting it. Okay, and polygon. Nope. There we go. Ground. Up one. There. And let's do the same for the bottom. That's nest. And let's run. Let's see. I think that's as far away as I can get with that. But I really should have it come all the way around this ground antenna. So I may end up moving it over. Just giving good clearance around everything. Probably get closer on these wires, give them more space around that. Not that it really needs it. It's not on the other side of that 12-foot wire, which I kind of like. Let's switch to the top view. Yeah, that looks good. It's connecting everything. Yeah, it looks like I've got everything. Let's see. So what I'm gonna do. Let's try and move the antenna in a way that would let me get full ground around it. Never hurts to beef up these traces. I want to change the width of that, the 12-volt track as well. Size, width, let's go to 24. I had a feeling that was going to happen. Let's do this. Whip up signal, and we can try that again. 24, go there. Native board. Yeah, okay, it keeps the ground plane around these antennas as well, so I'll leave, because when it did the ground fill, it did put the antenna, the ground around here, and on the board it does have that, so I'll leave that, but I'm going to put some V's in for it. That should be fine. That's completely overkill for trace width, but I will leave it. Again, probably overkill, but I'll leave it. And let's run check. Fine. We still have that wire stuck there. Fix things a million times and it still adds these stubs in quite often, and it's very annoying. Let's run it again. The only air wires should be for the ground plane. Was there something else I wanted to change and I just can't remember? Oh right, I wanted to put some vias. Ground. Okay. Let's do the polygon command. Found. Found. That's nest. Should connect it. Okay. Let's run the tools. Check. Yellow wire. Okay. Ground, 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 ground. Oh, missed that. It's 1, 2, 3. There should be a fourth wire I'm missing somewhere. I think I got everything. Well, let's try polygon again. No. Switch to bottom layer. Ground. That's nest. And side check. There, wire. Isn't the wire there? Okay. Weird. I'm amazed I didn't see that. There we go. Okay, hopefully this will be the polygon for the last time. We can only hope, right? Ground. Bottom. That's nest. Design check rule. Wire stub. Really? Ugh. See, like, it literally just added that. Because I didn't touch anything. But it seems to find it. Right when I... Because all I added was the wire up here, and it somehow messes it up down here. It's super annoying. Polygon again, it is. Oh, still showing the ground polygon. Well, it's showing the top layer polygon. So let's do a design check rule. Airwire. Where? Ground to ground. Why? Ah, so there is no connection between this ground plane and the ground plane over here. That's an interesting conundrum that I did not expect I would have. What's a way around that? Weird. Not an issue I expected to have. Well, it's polygon at the bottom, and I will be able to put in vias to fix that problem. But it didn't connect any of them. That's very annoying. Can I use the change tool? Mm. Oh, that's how you do it. Okay. So, used to have a looking at Google, and it said you could use the VIA tool, type in ground into the Eagle syntax, and it would allow you to connect the two planes together. Because right now there's this island right here that is not connected from the other ground, and I can't really see a good way of routing VDD or these signal wires um, to accommodate for that. So instead, I can use a VIA to go to the other ground plane and then come back up. But turns out the proper syntax is VIA ground. There we go. I guess it's changed over the years with the different versions, and you have to dig through some forum posts to find the info you want. I want this signal super grounded so that we don't have any issues. Because this chip for the radio receiver is actually a really good chip. I've hacked a few other devices that I needed the 433 signal to an Arduino, and it works very nicely, especially with its external crystal. Probably overkill with the VIAs, but again, it never hurts. At least I don't think it can. Could be wrong. Well, the mill's definitely going to have fun drilling them all out. What I am going to do is I don't think I'm going to have them immediately under the crystal, just because the crystal does have a metal body. I don't want to risk the silk screen getting scratched or anything and accidentally shorting or malfunctioning in a way that I don't want it to. Yeah. Should be able to click this button, click check, and there are no errors as indicated in the bottom left hand corner of the screen. I'm just going to click the rest of this button and click design check rules. No errors. Okay. We are done. That's it. That's it for this portion of the project. Next one is the battery management circuit. From there, I may make the 72-volt battery management system. Although that's probably going to be one of the largest ones. Maybe I'll do the lighting circuits, because they will also be small, rather simple. Arduino Nano, a NRF, a current sensor, and what do you call it? Not much. It's minimal. PCA 98 something. It's a PWM driver chip. That will also be on those lighting boards. But I think that's everything. Thanks for watching or checking out my stream. So that's a combination of almost 8 plus 5 hours designing this one board. Yeah, that's a fair amount of work.